Hey you, and welcome to the Sleepy Observer. This is your quiet harbour at the end of the day, a time to let the noise of the world fade and allow your thoughts to drift softly into the grand, silent expanses of the cosmos. Tonight, we are embarking on one of the most profound journeys imaginable. We will travel not just across distance, but across a chasm of time and space to ask a question that has stirred the human imagination for as long as we have known we were not alone in the universe. How long is the journey to the nearest galaxy? Our destination is a beautiful and sprawling island of stars known as Andromeda, our closest major galactic neighbour, and the answer, we will find, is not simply a number, but an invitation to contemplate the true, breathtaking scale of everything. Before we begin our slow voyage, I would love to know where in the world this story is finding you. Are you settling in for the night beneath a familiar sky, or is it another time of day for you? A moment of quiet pause stolen from the busyness of life. It's a quiet delight to imagine this constellation of listeners, all connected for a brief time by a shared sense of wonder, each observing from their own unique corner of our spinning world. If you find this journey helps you unwind or gently sparks your curiosity, a simple like and a subscription would be sincerely appreciated. And to those of you who are already part of this exploration, thank you. You are the quiet gravity that helps hold this little corner of the universe together. I will do my very best not to make the 2.5 million year journey ahead too exciting to drift off to. But if your thoughts do linger a little longer, at least you will fall asleep with a mind full of star-filled voids, ancient light, and a deeper sense of your own place in a universe that is far grander and more beautifully connected than we can ever fully grasp. So, let us begin our slow voyage and ask not only how long is the journey, but what would it mean to truly cross the quiet, star-filled ocean between our galaxy and the next? Our story begins in a place of familiar comfort, perhaps on a clear, moonless night, far from the glare of city lights. You look up, and the sky is a velvet canvas, strewn with the brilliant, steady points of stars and the soft, dusty ribbon of our own Milky Way. If you know exactly where to look, in the constellation of Andromeda, you might be able to spot something else. Not a star, not a planet, but a faint, elongated smudge of light, a ghostly wisp against the inky black. It is so faint, so unassuming, that you could easily miss it. Yet, what you are seeing is the most distant object that the unaided human eye can perceive. You are looking at the Andromeda Galaxy. To gaze upon that soft, distant glow is to peer across one of the greatest gulfs in the known universe. It is our cosmic neighbour, a sister galaxy to our own, and it contains perhaps 1 trillion stars, twice as many as our Milky Way. It is a place of swirling gas clouds, ancient star clusters, and a great bright core where stars are packed together in a luminous swarm, and it is very, very far away. The number that science gives us is almost impossible to comprehend, 2.537 million light-years. This number is so large that our minds, trained on the scale of meters and kilometers, of cities and countries, simply cannot grasp it. To even begin to understand it, we must first unpack the unit itself, the light-year. A light-year is not a measure of time, but of distance. It is the distance that light, the fastest thing in the universe, can travel in a single year. Light moves at a staggering speed, roughly 300,000 kilometers, or 186,000 miles, every single second. In the time it takes you to blink your eye, a beam of light could circle the Earth more than 7 times. A light year, then, is that incredible speed, sustained for 365 days. It is a cosmic measuring tape of almost unimaginable length, stretching for nearly 9.5 trillion kilometers, or just under 6 trillion miles. To say that the Andromeda Galaxy is 2.5 million light-years away means that the faint smudge of light you see tonight, the photons that are at this very moment striking the retina at the back of your eye, began their journey across the intergalactic void 2.5 million years ago. Let that thought settle in for a moment. When that light left its home galaxy, the Earth was a profoundly different world. It was the heart of the Pleistocene epoch, the Great Ice Age. Vast glaciers covered much of the northern hemisphere. Familiar animals like woolly mammoths and saber-toothed cats roamed the continents, and perhaps most astonishingly of all, our own distant ancestors, early hominids like Australopithecus, or the very first members of our genus, Homo, were taking their first tentative steps across the savannas of Africa. They would have looked up at the same night sky, but they would have had no language, no science, no way of knowing that a gentle stream of photons was just beginning its long pilgrimage toward a future in which their descendants would build telescopes and dream of the stars. The journey of that light is, in itself, a story of endurance. For 2.5 million years, those photons have travelled through the vast, cold emptiness between the galaxies. They have crossed the great cosmic dark, undisturbed, unwavering, moving in a perfectly straight line, carrying with them a snapshot of Andromeda as it was in the deep past. The Andromeda we see tonight is a ghost, a beautiful and ancient postcard from a time long before human civilization, before the pyramids, before writing, before the first fire was ever purposefully kindled by a human hand. And now, with this understanding of what it means to simply see our neighbour, we can turn to the more daunting question of what it would mean to go there. If it takes light, the universe's ultimate speedster, 2.5 million years to make the trip, how long would it take us? How would we even begin to traverse a distance so immense that it is measured in the travel time of light itself? This is not a journey of miles, but of lifetimes. It is not a question of navigation, but of enduring a scale of emptiness that makes our own solar system feel like a cozy, familiar room. To even contemplate this voyage, we must first leave our own home behind. We must cross the orbits of our planetary neighbours, sail past the furthest, coldest worlds of our solar system, and venture out into the great dark ocean that lies between the stars of our own Milky Way. Before we can set foot on the shore of another galaxy, we must first learn how to cross the endless quiet sea of our own. The spin of our own planet carries us at a gentle pace, but the journey to Andromeda demands a speed and a patience that challenges the very limits of what it means to be human. It is a voyage that begins not with an engine, but with an act of imagination, with the quiet courage to look up at that faint, distant smudge and wonder, what would it take to go there? To leave home, in the grand cosmic sense, begins with a single act of release. Our journey to Andromeda does not start by pointing a ship toward that distant smudge of light and pressing a button. It starts with the long, arduous process of escaping the gentle but persistent hold of our own planet. We must climb away from Earth, fighting its gravity, our engines burning with a quiet, focused fury, until we finally slip free from its embrace and drift into the silent, sunlit sea of our solar system. Only then, with our blue marble shrinking to a jewel behind us, does the first true leg of our journey begin. Let us imagine we are travelling in a vessel built with the very best of human technology. Let's grant it the speed of our fastest emissaries, the Voyager probes, which are currently sailing through interstellar space at a velocity of roughly 17 kilometers, or about 10.5 miles, every single second. At this speed, you could cross the entire United States from coast to coast in a little over 4 minutes. It is a velocity that feels breathtakingly fast by human standards. Yet, in the context of the cosmos, we will soon discover it is a mere crawl. With Earth now a beautiful distant memory, our first cosmic landmarks would be our planetary neighbours. We would pass the orbit of Mars, the quiet red world, in a matter of months. Then the great divide of the asteroid belt, a sprawling, sparse field of ancient rock and ice, the rubble left over from the solar system's construction. The journey through it would be long and quiet, not the dense, chaotic traffic jam of science fiction, but a vast and mostly empty space, punctuated by the occasional lonely tumble of a forgotten world. Years would pass on our vessel's clock. Outside our window, the sun would have shrunk to a brilliant but distinctly stellar point of light. It no longer feels like a sun, but like the brightest star in an unfamiliar sky. It is here that we encounter the true giants of our solar system. First, Jupiter, a colossal, swirling world of gas and storms, its great red spot a silent, churning eye. Our vessel, for all its speed, would take years to reach this king of planets. As we glide past its intricate family of moons, some icy, some volcanic, some perhaps hiding oceans of their own, we begin to get a true sense of the scale of our own backyard. The journey continues, pushing ever outward. Another decade or so would pass before we reach the elegant, ringed majesty of Saturn. From here, the sun is now just a distant spark, its warmth barely felt. The silence of space becomes more profound, the darkness deeper. Uranus and Neptune, the pale, icy sentinels of the outer solar system, would take decades more to reach. Each planet passed is a milestone, another tick on a clock that measures time not in hours or days, but in years and decades of steady, silent travel. After perhaps half a century of voyaging, we would have finally crossed the orbit of the farthest known planet. We have now reached the very edge of the familiar solar system, but we are still far from leaving home. We are still bathed in the sun's light, still embraced by its gravity, and still protected by the vast invisible bubble it blows out into space, the heliosphere. This is the region dominated by the solar wind, the stream of particles that our sun constantly breathes out into the cosmos. To truly begin our journey to Andromeda, we must first cross this final frontier. This is the task that our fastest pioneers, the Voyager 1 and 2 spacecraft, have already accomplished. Launched in 1977, they have travelled for nearly 5 decades, their instruments now old, their power slowly fading. Only in the last several years did they finally cross the heliopause, the boundary where the sun's solar wind yields to the faint, subtle pressures of the interstellar medium. It took them more than 35 years of constant travel at their incredible speeds to simply leave the sun's direct sphere of influence. Let us use their journey as our measure. At their pace, it takes the better part of a human lifetime to simply get out of the house. And where are they now? Drifting in the vast, quiet space between the stars of our own galaxy. The scale of this emptiness is what is truly humbling. From Voyager 1's current vantage point, our sun is just another star. The Earth is invisible, too small and too faint to be seen at all. And the stars, those same familiar constellations we see from our own backyard, look almost exactly the same. They are still just distant, shimmering points of light. We have travelled for decades, crossed billions of kilometres, and yet we have barely moved at all in the grand scheme of the galaxy. And this is where our imagined journey truly begins its lesson in patience. If we were to aim our Voyager-speed vessel toward the nearest star to our Sun, Proxima Centauri, a small, dim red dwarf just over 4 light-years away, how long would that journey take? The answer is staggering. At 17 kilometers per second, it would take our ship roughly 75,000 years to cross the distance to that single, nearest stellar neighbour. 75,000 years. That is more than 10 times the entire recorded history of human civilization. Great empires would rise and fall, languages would be born and forgotten. The very shape of the continents on Earth might shift, all while our tiny vessel sailed silently through the void, making its way to just the next star over. This single calculation changes everything. It reframes our understanding of what a journey to another galaxy truly means. Before we can even begin to contemplate the 2.5 million light-year chasm that separates us from Andromeda, we must first face the immense, almost soul-crushing emptiness of our own galactic neighbourhood. The space between the stars is not a gap, it is an ocean of unfathomable size, and our fastest ships are, in this ocean, little more than messages in a bottle, cast out with hope, destined to drift for ages. So, here we are, in our imaginary vessel. We have left the familiar warmth of the inner planets behind. We have passed the great cold gas giants. We have crossed the boundary of the sun's influence and entered the quiet realm between the stars. The journey, so far, has taken decades, and yet Andromeda is no closer, no brighter. It remains a faint smudge in our telescope, its light still carrying a message that is 2.5 million years old. We have only just stepped off our cosmic front porch, and before us lies a sea of stars that make up our own Milky Way, a sea that we must now learn to cross. To traverse our own galaxy is the second great leg of our journey, a prelude to the vast intergalactic void that waits beyond. Having spent a lifetime just to reach the quiet sea between the stars, we must now come to terms with the true architecture of our home. The Milky Way is not a mere collection of stars scattered at random. It is a city of unimaginable size, a grand, spiralling structure of breathtaking elegance, with neighbourhoods, thoroughfares, suburbs, and a bustling, brilliant core. Our sun and its family of planets reside in a quiet, modest suburb, a spiral arm known as the Orion Arm, about 2/3 of the way out from the galactic centre. From our vantage point, the Milky Way appears as that hazy, luminous band across the night sky, because we are looking at it from the inside, edge-on, through the thickest part of its flat, dusty disk. But if we could rise above it and gaze down, we would see its true form, a majestic spiral with a bright central bulge and great sweeping arms of stars, gas and dust, all rotating in a slow, graceful waltz around a supermassive black hole that slumbers at its heart. This city of stars is roughly 100,000 light-years across, 100,000 years for light itself to travel from one end to the other, and our task, in our hypothetical vessel travelling at Voyager's speed, is to cross it. The numbers here become so large that they begin to lose all meaning, so let us instead think in terms of proportion. The journey to the nearest star, Proxima Centauri, we calculated would take some 75,000 years. Proxima Centauri is, on a galactic map, practically on our doorstep. To cross the entire Milky Way at that same speed would take not thousands, not millions, but billions of years. To be precise, somewhere in the neighbourhood of 1.8 billion years. Let that number rest for a moment. 1.8 billion years. This is the travel time, using our fastest existing technology, to simply leave our own galaxy behind. During that time, the very sun that our journey began under would have brightened and grown, perhaps boiling the oceans of the Earth we left behind. Life on our home world would have undergone profound evolutionary changes. Mountain ranges would have risen and eroded to dust. The very concept of human civilization would be an ancient, forgotten memory, a fleeting archaeological layer in the deep strata of time, and our small, lonely ship would still be sailing, a silent, dark speck, through the star-filled avenues of the Milky Way. This journey through our own galaxy would be one of profound beauty and equally profound loneliness. For thousands upon thousands of years, we might travel without passing close to any other star system. The darkness between the stars is vast, a quiet and cold expanse filled only with a thin, almost imperceptible mist of hydrogen gas and cosmic dust. The stars themselves would remain distant points of light, their constellations shifting with agonizing slowness as our perspective changed over the millennia. But every few 100,000 years, our path might take us through one of the galaxy's spectacular celestial landmarks. We might glide through a stellar nursery, a vast glowing nebula where new stars are being born from collapsing clouds of gas. We would witness brilliant young blue stars blazing with fierce energy, illuminating the swirling dust around them in vibrant shades of pink and red. We might sail past the remnant of a long-dead star, the beautiful expanding shell of a supernova, its intricate filaments of gas still glowing with the energy of an ancient explosion. Or perhaps we would navigate through a dense globular cluster, a tight spherical swarm of hundreds of thousands of ancient golden stars orbiting the galaxy like a satellite city. Throughout this impossibly long voyage, Andromeda would remain our destination, but our relationship with it would change. From our new vantage points, deep within the galaxy, Andromeda would still appear as a distant island of light, but we would begin to appreciate that it is not a singular object, but a sibling. Our Milky Way is not alone in the universe. It is part of a small, gravitationally bound collection of about 50 galaxies known as the Local Group. Andromeda is the other great spiral in this group, our larger, more massive twin, and the two of us, Andromeda and the Milky Way, are slowly but surely falling toward each other. Pulled together by our mutual gravity, we are on a collision course. This is not cause for immediate alarm. The merger is still some 4.5 billion years away. But our long journey across the Milky Way would be undertaken with the quiet knowledge that our destination is also coming to meet us. This cosmic embrace, when it finally happens, will not be a violent crash of stars. The space between the stars is so vast that individual collisions will be extraordinarily rare. Instead, the two galaxies will pass through each other like ghosts, their gravitational fields tangling, their stars being pulled into long, streaming tidal tails, their forms distorted until over hundreds of millions of years they settle into a single new and even larger galaxy. Some astronomers have playfully named this future galactic merger Milkomeda. As we finally approach the edge of our own galaxy, after our journey of nearly 2 billion years, the view outside our window would transform one last time. Behind us, The familiar, dense river of the Milky Way would stretch across the sky, a breathtaking panorama of billions of stars, glowing nebulas, and dark dust lanes. And ahead of us, emptiness, a new kind of darkness, a void far more profound than the space between the stars. We would be on the shore of the intergalactic ocean, the great dark chasm that separates the islands of the cosmos. We have crossed our home city, we have seen its wonders and felt its immense scale, and the clock on our ship now reads a number so large it signifies a deep geological age. And yet, the longest part of our journey, the trip to Andromeda itself, has only just begun. The 100,000 light-years of our own galaxy are but a prelude, a short walk across the yard before stepping onto the long road that leads across the true wilderness of the cosmos. To leave one's home galaxy is to enter a silence of a different order. Having spent nearly 2 billion years crossing the star-filled plains of the Milky Way, our vessel now drifts at its very edge, poised on the brink of the true deep. The view from our window is one of profound and stark contrast. Behind us, the galaxy is a staggering spectacle of light, a flat, shimmering river of stars, nebulae, and glowing dust. A city so vast it fills half the sky. Its familiar spiral arms, now seen from an outsider's perspective, swirl with a silent, majestic grace. It is a sight of almost overwhelming beauty, the place we once called home, now revealed in its entirety. Ahead of us, however, lies something else entirely, the intergalactic void. It is a darkness deeper and more complete than any we have yet encountered. The stars of our own galaxy, which had been our constant companions, now begin to recede, their numbers thinning out dramatically. What remains is a profound and almost unnerving blackness, punctuated only by the impossibly distant, faint smudges of other galaxies. In this void, our nearest galactic neighbour, Andromeda, now becomes the most prominent feature in the sky ahead. No longer just a smudge, it has grown into a clearly defined, magnificent spiral, its bright core and sweeping arms beckoning from across the dark ocean. The journey across this chasm is the final and longest leg of our voyage. The distance to Andromeda is 2.5 million light-years, having already taken 1.8 billion years just to reach the edge of our own 100,000 light-year-wide galaxy. The math of our journey becomes almost nonsensical. At the speed of our Voyager-like probe, crossing the void to Andromeda would take an additional 44 billion years. 44 billion years. Let us let that number hang in the silence of our imagined vessel. This is a span of time that is more than 3 times the current age of the entire universe. It is a duration so vast that it extends beyond the expected lifespans of stars, beyond the stability of galaxies, perhaps beyond the era of matter as we know it. In such a time frame, our sun would have long ago exhausted its fuel, swelled into a red giant, and faded into a cold, dark, white dwarf. The Earth would be a cinder. The Milky Way itself would have completed its merger with Andromeda billions of years before our ship ever arrived. Our journey has become a paradox. By the time we reached our destination would have already come to us, merged with our starting point, and become part of a new, unrecognizable home. This realization forces us to abandon our faithful, Voyager-speed vessel. It is a wonderful tool for exploring our own solar system, a testament to human ingenuity. But for a journey between galaxies, it is like trying to cross an ocean in a rowboat. The scale of the task demands a new kind of thinking, a new kind of ship, one that can cheat the immense tyranny of distance. So let us leave our familiar probe behind and imagine, just for this quiet exploration, that we have a ship capable of travelling at a significant fraction of the speed of light. Let us say our new vessel can travel at 99.9% of the speed of light. This is a speed that is, for now, deep in the realm of science fiction, requiring energies and technologies we cannot yet fathom. But in this realm, the strange and beautiful rules of Einstein's relativity come into play. As an object approaches the speed of light, its experience of time slows down relative to the rest of the universe. This phenomenon, known as time dilation, would be our greatest ally on this impossible journey. For an observer watching from Earth, our ship would still take a little over 2.5 million years to reach Andromeda. The cosmic speed limit is absolute, but for the crew inside our ship, time would pass much more slowly. At 99.9% of the speed of light, the journey would feel not like millions of years, but like a mere century. The crew might age and pass the mantle of their journey to their children and grandchildren, but it would be a voyage measurable in human lifetimes, not geological eons. They would arrive at Andromeda while still remembering the Earth they left behind. And what would that journey across the intergalactic void be like? It would be an experience of profound isolation. For thousands of years of the ship's time, the view outside would be one of almost unchanging darkness. Behind them, the Milky Way would shrink, slowly from a majestic river of light into a beautiful but distant spiral. Ahead, Andromeda would grow, its own spiral arms gradually resolving from a soft glow into a tapestry of individual stars, and all around, the deep black would be dotted with the faint ghostly light of other, even more distant galaxies, each one an island universe separated by an even greater darkness. The space between galaxies is the closest thing the universe has to true emptiness. It is a near-perfect vacuum, far emptier than the space between stars within our own galaxy. There are no nebulae here, no star clusters, only a thin, almost undetectable mist of stray atoms, a cosmic whisper of hydrogen and helium known as the warm, hot intergalactic medium. Occasionally our ship might pass a lone, rogue star, one that was flung out of its home galaxy by a gravitational encounter billions of years ago. These stars, adrift in the eternal night, are the sole inhabitants of the void, their faint light a reminder that even in the greatest emptiness, there can be a solitary wanderer. To travel this void would be to experience a stillness that is absolute. There would be no sense of speed, for there would be no landmarks to rush past, only the slow, imperceptible shrinking of one galaxy behind and the gradual growth of another ahead. It would be a journey that demanded a deep and unwavering sense of purpose, a faith in the destination, for the path itself would offer little comfort beyond the steady, silent beauty of the cosmos, seen from its most lonely vantage point. And after a journey that lasted 100 years for the crew, but 2.5 million years for the universe they left behind, they would finally arrive. They would cross the faint outer halo of Andromeda and enter a new city of stars, ready to observe a world that had, from their perspective, aged by millions of years while they sailed through the timeless dark. To arrive at the shores of Andromeda, after such a long and quiet journey, would be an experience of breathtaking transition. Having spent generations in the profound, stark emptiness of the intergalactic void, our vessel would now be entering a realm of increasing richness and light. The crossing begins subtly. We first enter Andromeda's galactic halo, a vast, mostly invisible sphere of dark matter, ancient stars, and thin, hot gas that extends for millions of light years around the galaxy itself. The darkness is no longer absolute. A faint, ethereal glow would begin to permeate the space around us, the combined ancient light of 1 trillion distant suns. In this halo, we might encounter some of Andromeda's most ancient citizens, globular clusters, those tight spherical swarms of hundreds of thousands of old golden stars, drift through the halo like celestial beehives. Each one is a self-contained island of stars, born in the very early days of the galaxy's formation. To glide past one of these would be to witness a city of suns, their collective light casting a soft, warm glow, a stark contrast to the cold, lonely starlight of the void. We would also begin to meet Andromeda's dwarf satellite galaxies, dozens of smaller galaxies, each with a few million or billion stars, all bound by Andromeda's immense gravity. They orbit the great spiral like moths around a cosmic flame, some being slowly torn apart by its tidal forces, their stars trailing behind them in long, ghostly streams. As we journey deeper, moving from the outer halo towards the main galactic disk, the star density would increase exponentially. The sky, which had been mostly dark with a few prominent galaxies, would now begin to fill with individual stars, first a handful, then hundreds, then thousands, until we were no longer outside observers, but swimming within a new ocean of light. After generations of seeing our own Milky Way shrink into a distant jewel, the stars of Andromeda would now be our new constellations, our new celestial guides. The view would be one of both alien beauty and deep familiarity, for a galaxy from the inside is governed by the same gentle rules as our own. Upon entering the main disk of Andromeda, a flat, spinning plane of stars, gas and dust. Our experience would mirror our departure from the Milky Way, but in reverse. We would navigate through its grand spiral arms, vast, sweeping thoroughfares where star formation is most active. Here, the view would be spectacular. We would pass through immense glowing nebulae, clouds of hydrogen gas illuminated in vibrant pinks and purples by the fierce light of newborn stars. We would witness clusters of young, brilliant blue suns, blazing with an energy that tells us we are in a neighborhood full of youthful activity. The space here is richer, dustier, and more dynamic than the quiet suburb our own sun inhabits. Andromeda, being a larger galaxy than the Milky Way, is thought to have a higher rate of star birth, and we would see that vitality all around us. The structure of Andromeda is magnificent. Like our own galaxy, it has a bright central bulge, a dense sphere of older yellow and red stars that crowd around its core. This region would appear as a steady, luminous golden haze in the distance, a city centre towards which all the spiral arms are flowing, and at the very heart of this bulge, hidden from direct view by thick clouds of dust and a swarm of stars, lies Andromeda's own supermassive black hole. At an estimated 100 to 200 million times the mass of our Sun, it is far more massive than the one at the centre of the Milky Way, a true sleeping giant, quietly holding its vast kingdom of stars in a gravitational embrace. To a traveller arriving from another galaxy, Andromeda would feel both majestic and welcoming. The physics is the same. The types of stars, red giants, blue supergiants, steady yellow dwarfs, are all familiar. Planetary systems are likely as common here as in our own galaxy, and worlds of rock, gas and ice almost certainly orbit these distant suns. And while the constellations would be entirely new, the fundamental nature of the light would be unchanged. To be here would be to find a new home in the cosmos, a place that is at once entirely alien and deeply, profoundly familiar. It is worth pausing to reflect on the nature of our arrival. We have travelled at nearly the speed of light. For us, a century or so has passed, but in the universe we left behind, 2.5 million years have elapsed. From the perspective of any hypothetical astronomers left in the Milky Way, our vessel vanished on its journey centuries ago, and has long been presumed lost to the silent dark. Meanwhile, on Andromeda, we are the true aliens, visitors from a past so deep that their own civilization, if one exists, would have evolved from simple life to technological sophistication during the time we were in transit. We would be ghosts from the past, arriving in a future we can no longer recognize. This is the great and solemn poetry of relativistic travel. The journey shortens time for the traveller, but it also creates an unbridgeable chasm with the home they left behind. To journey to another galaxy, even in our fastest imaginable ship, is to accept a one-way ticket. There is no going back to the same world you departed. This thought itself brings a certain peace. Such a voyage would not be a mere trip, but a transformation, an acceptance of a new future in a new home, carrying with you only the memory of a distant, ancient blue dot that has long since moved on without you. We have arrived. We are now citizens of a new galaxy, adrift among its trillion stars, a single tiny vessel that has crossed the greatest ocean imaginable to stand on a new shore and gaze at an unfamiliar yet welcoming sky. Our arrival in the Andromeda Galaxy marks the end of one journey, but the beginning of another. To truly understand this new island of stars, to grasp its scale and history, we would now need to become what our channel's name suggests, quiet observers. Let us imagine our vessel finds a gentle, stable orbit around a calm, sun-like star in one of Andromeda's peaceful suburban spiral arms, a place not unlike our own solar system's neighbourhood. From this new perch, the universe would appear both alien and intimately familiar. The night sky from a hypothetical planet within Andromeda would be a spectacle of breathtaking richness, with perhaps twice the number of stars as our own Milky Way, packed into a disk of similar size. Andromeda is a more crowded and thus more luminous city. The band of the galaxy stretching across the night sky would be even more brilliant than our Milky Way. It would not be a soft ethereal ribbon of light, but a dazzling river of stars, so bright it might cast faint shadows on the ground. Dark dust lanes would cut through it in sharp, beautiful contrast, and the golden glow of the central bulge would be a constant, prominent feature in the sky, a permanent and gentle lighthouse in the cosmic night. And what of the view looking outward? From our new home, we would be able to see our own Milky Way galaxy in its entirety. No longer just a hazy band seen from within. It would now be a majestic external spiral. Our former home revealed as a beautiful distant island of light. We would be able to trace its spiral arms, pinpoint the location of our sun's long-faded ember, and watch our two galaxies continue their slow gravitational approach. This external perspective would grant us a kind of wisdom, the ability to see our own origins in their full cosmic context for the first time. To observe one's home from afar is a humbling and profound experience, a final, quiet letting go. Our work as observers would also involve listening. With advanced radio telescopes, we could tune into the hum of Andromeda, a symphony of natural cosmic signals. We would hear the sharp, rhythmic beats of pulsars, spinning neutron stars that sweep beams of radiation across space like cosmic lighthouses. We would detect the soft, static hiss of vast hydrogen clouds, the raw material for future generations of stars, and perhaps the faint radio whispers from the accretion disk of matter swirling around the supermassive black hole at the galaxy's core. Every signal would tell a story about the processes at work, the life cycle of stars, the distribution of matter, and the hidden dynamics of a galaxy in its prime. Observing Andromeda's stars would reveal a history both similar and subtly different from our own. It contains a greater abundance of older, metal-rich stars, especially in its sprawling halo and central bulge. This suggests that Andromeda may have had a more active and turbulent youth than the Milky Way, perhaps formed from the mergers of more large galaxies in the deep past. The stars it swallowed in those ancient collisions now live on as part of its vast, diverse population. As observers, we would be celestial archaeologists, reading the history of a galaxy not in stone but in starlight. But for all this grand observation, perhaps the most profound part of our new life would be the search for something familiar, a world that could support life, orbiting our new sun. There might be a planet not unlike Earth, a small rocky world with the right temperature for liquid water to exist on its surface. To land on such a world would be the true culmination of our journey. To step out onto its alien soil, to breathe its foreign air, and to feel the light of a new sun on our faces would be a moment of unparalleled significance. And what might we find there? Perhaps a world that is barren but holds the potential for life. Or maybe a world already teeming with its own biology, a place of strange and beautiful ecosystems that evolved entirely independently of our own. The plants of such a world might not be green, they might use different pigments to capture the light of their different sun. The animals might move in ways we have never seen, their forms sculpted by gravities, atmospheres, and evolutionary pressures entirely their own. To observe such a world would be a sacred and delicate task. It would be a chance to witness another story of life unfolding, a second Genesis, a separate and equally beautiful answer to the universe's quiet invitation for complexity. The question of whether we are alone in the cosmos would no longer be an abstract philosophical debate. We would have an answer, written in the very fabric of this new living world. Yet, even in such a place of wonder, a quiet melancholy might linger. The 2.5 million year time difference means that the humanity we left behind is a thing of the distant past. Any messages we sent back to Earth would be a call to ghosts. They would arrive at a world where our civilizations are ancient history, where our languages might be unintelligible, where the very species of Homo sapiens might have evolved into something new. Our first observation of a new home would be forever paired with the final quiet knowledge that we can never truly report back to the one we left behind. In this way, our journey transforms from a mission of exploration into one of preservation. We, the travelers, would become the sole keepers of Earth's memory, the living archives of a distant blue world. Our stories, our science, our art, all would be relics of a place that exists for us now only in memory, a star in our new sky that is not just a sun but a gravestone. This is the profound and solemn bargain of interstellar travel. To reach a new world, one must be willing to become an artifact of the old. But in that bargain, there is also a profound beauty. Life has an incredible and persistent drive to move forward, to carry its stories into new territories, and in our quiet vessel, orbiting a star in a galaxy 2.5 million light-years from home. Humanity, in this imagined future, would have done just that. We have become observers of a new heaven, keepers of an old earth, and a single tiny point of consciousness adrift in the endless, beautiful sea of stars. To ask how long a journey takes is, as we have seen, to ask two very different questions. There is the time that passes for the universe, the long, slow, and impartial ticking of the cosmic clock. And then there is the time that passes for the traveller, a personal and elastic experience that can stretch and shrink according to the laws of relativity. For our journey to Andromeda at near light speed, the two are profoundly different, 2.5 million years for the universe, and a single century for us. But there is a third, and perhaps even stranger way to consider the length of this journey, a way that does not involve ships, engines, or the steady passage of years. This is the journey of information itself, a voyage undertaken not by matter, but by the quiet and massless messengers of the cosmos. Imagine we choose not to travel to Andromeda ourselves, but instead decide to observe it with the greatest possible patience, using the most powerful tools imaginable. We stay on Earth, and we let the light come to us. As we have already learned, this light is a time capsule, carrying a picture of Andromeda as it was 2.5 million years ago. But this is not a static picture. With every passing moment, new light arrives, telling a story that is ever so slightly younger. By watching over long periods, we could, in theory, see Andromeda's own history unfold, albeit in extreme slow motion. Each year of observation on Earth would reveal another year of Andromeda's past. We would be watching a film whose frames arrive at a rate of 1 per year. But light is not the only messenger that crosses the intergalactic void. Gravity, too, sends its own quiet signals in the form of gravitational waves, ripples in the very fabric of space-time. When two massive objects, like black holes or neutron stars, collide within Andromeda, they would send out a burst of these waves that travel across the cosmos at the speed of light. Our gravitational wave detectors on Earth, like LIGO and its successors, are in a sense intergalactic listening posts. They are not waiting for matter to arrive, but for the faint, silent tremor of space-time itself, carrying news of cataclysmic events that happened millions of years ago in another galaxy. To detect a gravitational wave from Andromeda would be to hear its most dramatic cosmic events, a way of observing its most secret and violent moments from across an unimaginable distance. There is another, even more elusive messenger, the neutrino. These tiny, almost massless particles are produced in the nuclear furnaces of stars and in the chaos of supernova explosions. They are so ethereal, so non-interactive, that they can pass through entire planets, stars, and galaxies without ever touching a thing. Trillions of them are passing through your body right now, completely unnoticed, but very occasionally, one will strike an atom in just the right way to be detected. Great underground observatories, vast tanks of purified water lined with sensitive detectors, have been built to catch these cosmic ghosts. To detect a stream of neutrinos from a supernova in Andromeda would give us a real-time, or rather a 2.5 million year delayed time, view into the very heart of an exploding star. The light from a supernova might be obscured by dust, but the neutrinos would travel straight to us, carrying a clear and unfiltered story of the star's final moments. In this sense, the journey to Andromeda is already happening. It is a journey of reception, of patient observation. We do not need to build ships that cross the void. We can simply build receivers that can catch the faint ancient signals that are already arriving at our shores every single day. The light, the gravitational waves, the neutrinos, these are Andromeda's own emissaries, sent out in all directions, carrying fragments of its story for anyone patient and clever enough to listen. This form of travel by information, has its own unique relationship with time. The delay is immense, but the experience is immediate. We do not have to wait billions of years on a ship. We can see the images, hear the gravitational chirps, and count the neutrino flashes now, as they arrive. And through this patient collection of data, we can piece together a picture of Andromeda that is far more detailed than anything we could achieve by a single physical voyage. A single spaceship would arrive at a single point in time, in a single location. But through observation from Earth, we can survey the entire galaxy across different wavelengths, and through different cosmic messengers, building a rich four-dimensional map of our neighbour in both space and time. There is a quiet and beautiful humility in this approach. It acknowledges that the universe is vast, and our ability to travel through it is profoundly limited, but it celebrates the power of the human mind to bridge those immense distances through curiosity, ingenuity, and observation. Our greatest strength may not be our ability to build faster engines, but our ability to build more sensitive eyes and ears. We travel the cosmos not with our bodies, but with our intellect. Perhaps this is the most realistic and most meaningful journey to the nearest galaxy. Not a physical voyage measured in years or fuel, but an ongoing scientific and philosophical voyage measured in knowledge gained and wonder experienced. Every new telescope that comes online, every new gravitational wave detector that begins to listen, is another ship launched on this great journey. And with every new discovery, every new image of a swirling nebula in Andromeda, every faint signal of a distant pulsar, we travel a little farther, we understand a little more, and the vast cold distance between our two galaxies shrinks, just a little, in our minds. In the end, the longest journey may be one of perception, and the greatest voyages may be the ones we take while standing perfectly still, simply observing the quiet, steady stream of light that has travelled for millions of years just to greet us. Our exploration of this immense journey has so far been grounded in the realm of the possible, however improbable. We have considered voyages at speeds we understand, through the lens of physics we can trust, but the human imagination, when faced with an impassable gulf, has always been fond of asking, what if we could cheat? What if there were a way to sidestep the tyranny of the speed of sea, a cosmic shortcut that could turn a journey of millions of years into something manageable, perhaps even instantaneous? This is the realm of speculative science, of theoretical physics, and grand, unproven ideas. Yet, to fully appreciate the length of the journey to Andromeda, it is worth pausing to dream, just for a moment, of the ways we might one day bend the rules. One of the most enduring and captivating ideas is that of the wormhole. First conceptualized within the framework of Einstein's general theory of relativity, a wormhole is a hypothetical topological feature, a kind of tunnel or bridge through the fabric of space-time. It could in theory connect two vastly distant points, allowing for near-instantaneous travel between them. Instead of travelling through space, a wormhole would allow a traveller to journey outside of it, taking a shortcut that isn't a path in the traditional sense, but a warping of the map itself. Imagine our universe as a large sheet of paper. To get from one point to another, you must trace a long line across its surface. This is conventional travel, limited by the speed of light. But what if you could simply fold the paper, bringing the starting point and the destination right next to each other, and then poke a small hole through both layers? This is the essence of a wormhole. The journey would no longer be across the flat expanse of the paper, but through a new third dimension, a shortcut that turns a journey of light years into one of mere meters. If such a structure could be created and stabilized between the Milky Way and Andromeda, our journey of 2.5 million light-years would become trivial. One could step through a gateway on the outskirts of our own solar system and emerge moments later in the halo of our galactic neighbour. Time dilation would be irrelevant. The paradoxes of leaving home behind would vanish. The journey would be less a voyage and more a simple act of transit. But the challenges, as you might imagine, are monumental. For a wormhole to be traversable, to be large enough for a ship to pass through, and to stay open long enough for the passage, our current understanding of physics suggests it would require a form of matter with bizarre and exotic properties. Specifically, it would need negative energy or negative mass to prop open the throat of the wormhole, preventing it from collapsing into a singularity under its own immense gravitational forces. We have never observed such exotic matter. While quantum mechanics allows for tiny, fleeting fluctuations of negative energy in the vacuum of space, harnessing enough of it to stabilize a galaxy-spanning tunnel remains far, far beyond any technology we can conceive. Wormholes are, for now, beautiful mathematical possibilities, elegant solutions to Einstein's equations, but they remain firmly in the realm of theory. Another dream of faster-than-light travel is the warp drive. Popularized in science fiction, the idea is not to break the cosmic speed limit locally, but to cheat it by moving a bubble of space-time itself. In a theoretical model proposed by physicist Miguel Alcubierre, a ship would be enclosed within a region of normal space-time. Behind this bubble, space-time would be rapidly expanding, pushing the ship forward, while in front of it, space-time would be contracting, pulling it along. The ship inside the bubble would feel no acceleration, it would be peacefully at rest. But to an outside observer, the bubble itself would be moving at a speed that could, in theory, be many times the speed of light. It's a clever way around relativity's rules. Nothing is moving through space faster than light. Instead, space itself is the engine. The journey to Andromeda could be reduced from millions of years to a matter of months or years, all without the traveller experiencing any strange time dilation effects relative to their immediate surroundings. However, like the wormhole, the warp drive comes with a colossal energy bill. To create the necessary distortions in space-time, it would require vast amounts of that same elusive negative energy. Some calculations suggest it would need more energy than exists in the entire observable universe. It also comes with other rather inconvenient side effects, such as potentially annihilating your destination with a blast of high-energy particles upon arrival. For now, the warp drive remains a fascinating theoretical toy, a testament to the strange flexibility of space-time, but not a practical blueprint for our journey. These speculative ideas, wormholes and warp drives, are beautiful because they acknowledge the profound challenge that the journey to Andromeda represents. They are an admission that with our current understanding, the physical crossing is all but impossible for a species with a lifespan as short as ours. These dreams of shortcuts are humanity's way of wrestling with the infinite, of trying to find a clever backdoor in a universe whose scale seems designed to keep us home. And perhaps, in the deepest, most uncharted territories of physics, there are other possibilities we haven't even begun to imagine. Perhaps our understanding of space, time, and dimensionality is still in its infancy. But as we observe the cosmos from our quiet corner, these dreams of faster travel serve a profound purpose. They stretch our minds, they push the boundaries of what we believe is possible, and they underscore the sheer breathtaking majesty of the distances involved. To need a wormhole is to truly appreciate the 2.5 million light-year gulf. To dream of a warp drive is to feel the weight of every one of those countless empty kilometers between here and Andromeda. As we contemplate the unimaginable gulf that separates our home from Andromeda, an even deeper and perhaps more profound question begins to surface. It is a question that shifts our focus from the mechanics of travel to the very purpose of it. Why would we even want to make such a journey? What is this quiet, persistent yearning that draws our gaze to that faint, distant smudge of light in the sky? A yearning that has inspired myths, fueled science, and coloured our dreams for centuries. The answer, I believe, lies not in the hope of finding new resources or escaping a dying world, but in a far more fundamental human impulse, the search for connection, and the deep, quiet need to know if we are alone. For almost all of human history, the universe consisted of this world, our sun, our moon, and the familiar, unchanging patterns of the stars. We were, as far as we knew, the centre of everything. But as our observations grew more sophisticated, our cosmic address has become progressively more humble. First, we realized that the Earth was not the centre of the solar system, but just one of several worlds orbiting the sun. Then we discovered that our sun was not a special singular star, but just one of hundreds of billions in a vast spinning galaxy called the Milky Way. And finally, with the observation of distant spiral nebulae like Andromeda, we learned that our own galaxy was just one of countless billions of other island universes, scattered across a vast and expanding cosmos. With each of these revelations, our place in the universe became smaller, but our sense of wonder grew larger, and with that wonder came the great silent question: if there are so many stars and so many galaxies, could it be that we are the only ones looking up and asking these questions? To journey to another galaxy is, in its purest form, an attempt to answer that question. It is an act of reaching out, not with a message, but with our very presence, to see if there is anyone else out there to greet. The distances involved are so immense that they almost seem to act as a cosmic quarantine, designed to keep galaxies separate, each one a self-contained experiment in chemistry and biology. The journey to Andromeda, in this light, feels less like a trip across town, and more like a search for a lost sibling, a twin from whom we have been separated since the birth of the universe. We share a common origin in the aftermath of the Big Bang. Our galaxies were built from the same primordial hydrogen and helium. The same laws of physics govern the stars in Andromeda as they do in our own Milky Way. We are made of the same stardust. Given these profound similarities, it is almost a mathematical imperative to wonder if life, and perhaps even consciousness, has not also taken root in the soil of some distant, forgotten world, orbiting a star in one of Andromeda's spiral arms. This is the great and solemn hope that underpins much of our fascination with space. It is the belief that life is not a miraculous accident, confined to this one small blue planet, but a natural and perhaps even common outcome of the universe's own quiet, persistent chemistry. We look to Andromeda not as an empty collection of stars, but as a place of possibility. A trillion suns means a trillion chances for worlds, and among those worlds it feels almost inevitable that some would be in the right place, with the right ingredients for life's story to begin anew. A journey to Andromeda, then, becomes a pilgrimage. It is a voyage undertaken not for conquest, but for confirmation. The prize at the end is not territory, but knowledge. The quiet, world-changing knowledge that the universe is not a silent, empty place, but one that is humming with life. Even if we were to arrive at Andromeda and find no advanced civilizations, no cities of light, no radio signals whispering through the void, the discovery of even the simplest, most humble forms of life would be the most profound discovery in human history. To find a single microbe on an alien world, a single strand of something resembling DNA or its equivalent, would tell us that the genesis of life is not a singular event. It would transform our understanding of our own existence from a fluke of chemistry into a universal principle. This is the deeper meaning of our long and quiet journey. The question, how long does it take, is ultimately a question of hope. It is a measure of the chasm that separates us from a potential answer to our oldest question. The 2.5 million light-years are not just a distance, they are a silence. A long and profound silence that we have been filling for centuries with our own stories, our own dreams, and our own science. And perhaps in a strange and beautiful way, the immense difficulty of the journey is part of its meaning. The universe does not give up its greatest secrets easily. To learn them, we must be patient, persistent, and humble. We must be willing to accept that the answers we seek may lie far beyond the reach of a single human lifetime. The journey to Andromeda reminds us that our story is not just about us. It is part of a much larger, much older narrative, one whose chapters unfold on timescales that make our own lives seem like a fleeting breath. To undertake such a voyage, even in imagination, is to align ourselves with that deeper time, to become patient observers of a story that will continue long after we are gone. And in that, there is a kind of peace, a quiet acceptance of our place in the grand, silent and beautiful unfolding of the cosmos. Our imaginary voyage, in its near-light-speed vessel, has carried us to a new shore in the Andromeda Galaxy, a journey that felt like a century to its crew, but spanned millions of years for the universe they left behind. But there is another journey to Andromeda, one that has already been decided by the silent and patient laws of gravity. This is not a voyage we must choose to undertake, but one that is being undertaken for us. It is the great and inevitable merger, the slow-motion collision between our Milky Way and the Andromeda Galaxy, a cosmic event that has been unfolding since the dawn of time and is destined to reshape our celestial home. The two great spirals of the local group, the Milky Way and Andromeda, are not static islands in an empty void. They are the two most massive members of a small galactic family, and their mutual gravitational attraction has been gently but inexorably pulling them closer together for billions of years. Though the universe is expanding on its largest scales, pushing distant galaxy clusters farther apart, this expansion is not strong enough to overcome the local gravity between close neighbors, and Andromeda is, in cosmic terms, very close. Astronomical observations, particularly of the blue shift in Andromeda's light, have confirmed this trajectory. Unlike the vast majority of galaxies which are red-shifted as they are carried away from us by cosmic expansion, Andromeda is one of the few that is moving towards us. Its light is being compressed, shifted to bluer wavelengths, a clear and unmistakable sign of its approach. The two galaxies are hurtling toward each other at a speed of roughly 110 kilometers, or about 70 miles, every single second. At that speed, It may seem as though the collision is imminent, but the distances, as always, are vast. Even at this incredible velocity, the merger is not expected to begin in earnest for another 4.5 billion years. This is a timescale that is comfortably long, far beyond any immediate human concern. Our sun will, by then, have started to swell into a red giant, its aging process well underway, and the Earth will likely have long since become uninhabitable. This future galactic collision, therefore, is not our story, but the story of the worlds that may come after us. And what will this collision look like? The term itself is a bit of a misnomer, as it conjures images of violent, destructive crashes. In reality, a galactic merger is a far more graceful and creative process. The space between the stars within a galaxy is immense. While the galaxies themselves are colossal, they are made up mostly of empty space. As the Milky Way and Andromeda begin to pass through each other, the chances of any two individual stars actually colliding are infinitesimally small. For the most part, the two star fields will slide past each other like two ghostly swarms, their individual members almost never touching. The real interaction will be gravitational. As the two great masses interpenetrate, their immense gravitational fields will tangle and warp. Stars from both galaxies will be pulled from their familiar orderly orbits and flung into long, looping, chaotic trajectories. Great tidal tails, vast streamers of stars and gas hundreds of thousands of light-years long, will be drawn out into the space around the merging galaxies, painting the sky with sweeping, luminous arcs. From a distant vantage point, this merger would be one of the most beautiful and spectacular events in the cosmos. A slow-motion dance of two spirals, unwinding and reforming into something new. The process will not be a single event, but a series of close passes. The two galaxies will first swing past each other, distorting each other's forms, before their gravity pulls them back together for another, closer encounter. After several of these passes, over a period of hundreds of millions of years, they will have lost enough momentum to finally coalesce. Their individual identities will blur, their spiral arms will dissolve, and a new, single, and even more massive galaxy will be born from their union. This new galaxy, which some astronomers have nicknamed Andromeda, will likely be a giant elliptical galaxy, a vast, smooth, and somewhat featureless sphere of older stars. The great clouds of gas and dust that once fueled vibrant star formation in the spiral arms of both the Milky Way and Andromeda will have been used up in a final brilliant burst of starbirth triggered by the merger. The resulting galaxy will be a quieter, more settled place, its youth of active creation now behind it. And what would become of our sun, or what is left of it, in this new, larger home? It, along with its family of planets, would almost certainly survive the merger, but its location and its view of the cosmos would be forever changed. It would be thrown from its familiar orbit in the quiet suburbs of the Milky Way into a new and perhaps more central path within the larger Andromeda Galaxy. The night sky, from the perspective of a future Earth or one of its descendants, would be completely transformed. No longer a familiar, gentle Milky Way, the sky would be filled with the bright, dense glow of the new galactic core, a far richer and more star-filled panorama than any we have ever known. This great merger is the final, ultimate answer to the question of our journey. How long is the voyage to Andromeda? In a very real and beautiful sense, the journey is already underway, and it has been since the beginning of time. We do not need to build a ship or fight against the void. We are all passengers on a much larger vessel, the Milky Way galaxy itself, which is already sailing quietly through the cosmos, on a slow but certain course to meet its twin. The duration of this journey is 4.5 billion years, and the final destination is not a new world, but the forging of our own world into something new. Our contemplation of the journey to Andromeda, a voyage spanning distances so vast they stretch our very understanding of time and space, ultimately circles back to a quieter, more intimate destination, our own minds. The physical voyage may be a thing of distant, speculative futures, but the imaginative journey is one we can all take, right here and now, from the soft and gentle stillness of our own quiet corners of the world. To look up at the night sky, to see that faint, ancient smudge of Andromeda, is to engage in an act of observation that is profoundly human, an act that has echoed through the ages. For millennia, human beings have gazed at the stars and wondered. The questions have changed, the tools have grown more sophisticated, but the underlying impulse has remained the same. It is a sense of awe, a quiet humility in the face of a universe so immense and so beautiful that it seems to demand reflection. The journey to another galaxy, in this sense, is not just a problem of physics and engineering, but a deep philosophical meditation on our place in the cosmos. It forces us to confront the scale of our own existence and the profound rarity of our small living world. To think about the 2.5 million years it takes for light to travel from Andromeda is to recalibrate our sense of time. Human history, with its empires and inventions, its triumphs and tragedies, shrinks to a mere footnote in the cosmic calendar. This is not a thought that should make us feel insignificant, but rather profoundly fortunate. We are alive in a moment, a brief, shimmering instant in the universe's long story, and in this instant we have been granted the awareness to look up and appreciate the view. The light from Andromeda did not travel all this way for us, of course. The universe is not performing for an audience, but our ability to receive that light, to understand what it is, and to be moved by its ancient silent journey is a quiet miracle in itself. This imaginative voyage also teaches us about the nature of home. To dream of leaving the Milky Way is in a beautiful paradox to understand it more deeply. By contemplating the emptiness of the intergalactic void, we come to appreciate the richness of our own stellar city. The stars are not just scattered points of light, they are our neighbours. The dust lanes are not just dark smudges, they are the fertile grounds from which new worlds will be born. Our galaxy is a living, breathing ecosystem, a place of connection and community on a cosmic scale. To even begin the journey to Andromeda, we must first appreciate the vastness of the home we are leaving behind, and in doing so our connection to it deepens. The question of the journey's length also becomes a quiet reflection on patience. In a world that often values speed and immediacy, the cosmos operates on an entirely different schedule. Stars are born over millions of years, galaxies merge over billions, light travels for eons, carrying its stories with unwavering persistence. The universe is in no hurry, and it teaches us, if we are willing to listen, the deep and profound power of slow, steady processes. The journey to Andromeda, in this light, is not an impossible problem to be solved with a burst of technology, but a humbling reminder that some things in the universe unfold at their own pace, and that our role may simply be to observe, to learn, and to wait. There is a deep and soothing calm that can be found in this perspective. The small, urgent worries of our daily lives, when set against the backdrop of a 2.5 million light-year journey, can begin to feel a little lighter, a little less overwhelming. Our own lifespans are but a flicker, but we are part of a story that is ancient and enduring. The atoms in our bodies were forged in stars that lived and died long before our sun was born. We are, in the most literal sense, made of the same stardust that makes up the galaxies we long to visit. We are not separate from the cosmos, we are a part of it, a momentary and beautiful configuration of its own ancient matter. This quiet, contemplative journey to Andromeda, taken within our own minds, may be the most important one of all. It requires no fuel, no ship, no faster-than-light technology. It requires only a still moment, a curious mind, and a willingness to be humbled by the sheer majestic scale of it all. It is a journey that connects us, not just to a distant galaxy, but to every human being who has ever looked up at the night sky and felt that same sense of wonder. From the ancient shepherds who first traced the constellations, to the astronomers who first measured the distance to the nebula, to you, right now, listening in the quiet of the night, we are all fellow travelers on this voyage of the imagination. And so, as we begin to drift toward our final destination in this exploration, the journey becomes less about arriving and more about the act of traveling itself. The true beauty of Andromeda may not be in what we would find if we were to get there, but in what it inspires within us from here. It is a cosmic anchor for our wonder, a distant lighthouse that reminds us of the vast, unexplored ocean of the universe. And in its faint, steady light, we find not just a destination for our dreams, but a quiet, constant invitation to keep looking up. Our long, quiet voyage, undertaken in the gentle vessel of the imagination, now brings us back to where we began, a peaceful night on a small, spinning world, gazing up at a faint and distant smudge of light. We have crossed the solar system, traversed the starry avenues of our own Milky Way, and sailed the silent, profound emptiness of the intergalactic void. We have contemplated the strange and beautiful rules of relativity, dreamed of shortcuts that bend the very fabric of space, and watched as our own galaxy sails slowly but surely toward an inevitable embrace with its cosmic twin. And through it all, the question has lingered: how long is the journey to the nearest galaxy? The answer, we have found, is not one number but many. For our fastest machines, it is a journey of billions upon billions of years, a timescale so vast it is functionally eternal. For a traveller in a ship of dreams, one that rides the very edge of light, it is a journey of a human lifetime, but a lifetime bought at the cost of leaving a world behind. For the light itself, the quiet messenger that makes our question possible, the journey is 2.5 million years old, an ancient story that arrives fresh with every passing second. And for our two galaxies locked in a gravitational dance, the journey is a slow 4.5 billion year waltz, a voyage that requires no effort at all, only the patient and inescapable pull of gravity. Yet, perhaps the most meaningful answer is the simplest one. The journey to Andromeda is as long as a moment of quiet observation. It is the time it takes to step outside on a clear night, let your eyes adjust to the darkness, and find that faint, ghostly glow in the sky. In that moment you have bridged the distance. Your awareness, your curiosity, your sense of wonder has crossed the immense gulf and connected you, for a brief instant, to a city of 1 trillion other suns. In the truest sense, the journey is one we can make any time we choose. This perspective, this quiet shift from the physical to the philosophical, is the true heart of our exploration. The universe is immense, and we are small, its timescales are eternal, and our lives are fleeting, but in the act of observing, of learning, of contemplating, we become participants in its grandeur. We are not just inhabitants of the cosmos, we are its consciousness, the part of it that has, for a brief and beautiful moment, woken up to itself. The knowledge that the Andromeda Galaxy is 2.5 million light-years away does not push it further from us. In a strange way, it brings it closer. It gives it a story, a history, a context. It is no longer just a smudge, but a destination for our thoughts, a place that was shining its light long before our own species walked the Earth, and to know that our own galaxy is moving towards it, destined for a cosmic merger in the deep future, gives us a profound sense of our place in an unfolding narrative. Our story is not a solitary one, it is part of a much larger, much longer conversation between galaxies. And so, as this quiet journey comes to a close, and you prepare to drift into the peaceful void of sleep, let this final thought be your companion. The universe does not ask us to conquer it. It does not demand that we build ships to cross its every ocean. It asks only that we observe it, that we listen to its ancient light, that we feel the gentle rhythm of our own spinning world, and that we find a sense of peace in our small, yet profoundly beautiful place within it all. The journey to the nearest galaxy may be impossibly long for our bodies, but it is always just a single, quiet thought away for our minds. The stars in Andromeda will continue their slow and silent waltz. Our Milky Way will continue its graceful journey toward them. And here, on this small blue world, we will continue to look up and wonder. And in that shared and timeless act of observation, we find our deepest and most enduring connection to the vast and beautiful cosmos we call home. May that thought bring you calm, may it bring you peace, and may it gently guide you into a restful night's sleep.